Hello Internet, welcome back to our ripple shader. We are building a ripple shader. We've actually done this already, but we're doing it in Shader Graph this time, and there's a few things that we need to add to our current solution. We have this circle in the background. Ignore this cube. That's from a step shader we were working on previously. We're actually going to do some of that stuff here, but for the most part we care about this. A sphere that's a plane. One sec. I'm going to delete that there. That was confusing. So our sphere is a plane. And so we are going to be making this better. Specifically, what I want to be able to do is add in a parameter. Right now, this circle is always centered at 0, 0, 0. So even if I move my plane itself, that circle stays there. That's what I want, but I want to be able to move it in space. And there is no way to do that right now. These are our options over on the right here. And there's no options for where that circle appears. So we want to add that. While we're doing that, there's a few things that I need to change because I got a different computer and this one seems broken. Or at least this project seems broken now that we're on this computer. Because you'll notice we have this world space distance function. This is a subgraph that we created in the previous video. It doesn't work anymore. I mean, obviously our shader still works, but I can't edit this. It's just empty. It throws a bunch of exceptions, and I have no idea what happened. I don't know what's going on. I can't work with it. So that's just broken. We're gonna just get rid of that, I think, because it just wasn't as useful as I thought, and it just seems like it doesn't work as well as I thought. So I just don't think that's a great step. Speaking of steps, we are also going to use a step function instead of this comparison and a branch. So we're going to be swapping that in as well. And that should hopefully just make this a little bit cleaner. We can use what we learned in that previous video, dealing with steps and smooth steps. Right now we don't need a smooth step, but we will in the future. So it makes sense to kind of step in that direction. Pardon the pun. So what we want to do first is, I'm actually kind of curious if I change this value like to a 5, for example, and save this. Does anything happen? Does it work? Does it change? Does anything do anything? It doesn't look like it. And so the reason I'm testing this is because I'm curious if it's compiling at all. It seems like our shader, this shader graph thing, is just totally broken at this point. Because what I would expect is I would expect this to expand, and then the circle should then be everything inside of 10. 10 units should be green, and everything outside should be blue. That didn't happen. So I'm feeling like we broke something here. So I think the solution is to delete this. If I can. I can't. Okay, great. I don't know what's going on here. I guess we're making a new thing. I don't have an answer. It's not working. So I guess we're just gonna copy all of this over, and really there isn't much here. A lot of the work we did was in that world space distance thing, so seems like it's broken. I don't know how to fix it. I don't know what's going on. It's just throwing null pointer exceptions, and that's not enough for me to fix it. So we're going to create a new Pbr graph. Actually, let's not do that. Getting ahead of myself. Well, changing the plan. Let's create an unlit version. We already have the Pbr thing. That's great. Let's do an unlit ripple shader graph shader. I should start naming these better, but I want to do unlit because one, we're getting these, it makes it really hard to get like really darks. And the end goal for this is that everything you see is only going to be in the ripples. So I want the screen should be entirely black except for those ripples. And we can't do that with a public or a physically based render because it's going to take light from every other source, and that just isn't what we want in this specific effect. So when we create this, we get a lot less options because if we want to add light, we have to actually calculate that ourselves. But I think that's what we want. So we have just a color output in alpha and then a clip threshold, which is actually going to affect whether something is drawn or not. And I think, pretty sure this is what we want. So let's dock this here. And then we can use this as a reference to kind of figure out what we want. And so first things first, let's add some properties. This blackboard thing seems to be how you do that. And it's a two-step process. So the first is going to be our ripple location. So we just add these values effectively. And this will be our inside color. And we'll have another color for our outside color. And so outside, we want that to just be black, like so. And inside, we'll make that yellow. Let's do like purple, sure. It doesn't really particularly matter, but you can pick whatever you think looks nice. And so those exist now, but it isn't actually being particularly helpful to us. What I actually want to be able to do is access those. And so there's a properties thing. And so if you type property, these will pop up. I don't actually know where they show up in this whole thing. Oh, under properties. That makes sense. I don't think that option shows up if you don't have any properties specified, but if you do, all of them will show up. They'll match the same thing. And I imagine if you rename them, they should match. So what we're going to do is take our ripple location and subtract that from a world space position. And so this is similar to what we were doing previously to get this effect. We are going to do a subtract of our world space from our ripple space, like so. Let's not overlap those. Try to make this a little bit less messy. There we go. And we can shrink that for now. There we go. And we'll put that over there. Okay. Making a mess, but that's fine. And then we're just going to actually put this as the color output for now. And I think that will be a nice way to kind of see what's happening. Because what I should be able to do at this point is save this. And then apply this to our ripple shader graph. And we'll get something like this. Now this is going to get increasingly bright in this direction. I have bloom enabled. And so it's actually going to appear like it's glowing pretty significantly. The reason it looks like that is because it's actually going beyond 1, I believe. It actually may be clipping because I don't think HDR works with this. Doesn't look like it's doing anything, but it will exceed 1 at those points because it's based off of the world space position. That's not really what we want for the color, but what we should be able to do is go into our, I'm going to rename this as a plane because it's not a sphere. We should be able to see our ripple location, our inside color, and our outside color labeled here as properties. And so I should actually be able to change like the X, and it should change along that thing. So if we move our plane on the X axis in the positive direction, you can see it also moves in that same direction. So theoretically, this is actually doing what we think it's supposed to do. That's good because otherwise we wouldn't be doing our job. And so the next bit that I want to add is a ripple test, effectively, to see if it's inside or outside. And so we're going to use a step function for that. And I don't exactly remember if it's greater than or less than or what for this, but what we want is the distance, the magnitude of this vector, the subtracted vector, to be less than some value. So I don't actually want to plug it in like I'm doing here. That's not quite correct. Instead, we want to get a magnitude, a distance, like so, and plug that in. Oh, we don't even need to subtract them. I can just literally plug in these two, get a distance, and we're good. And then this can go into our step function. And then we're going to want some other parameter, which is going to be our vector 1. That's an odd name for that. But we're going to want our ripple radius. Not the best name, but it'll work. And so let's grab our ripple radius and plug that into the bottom bit. And so this should now give us an output, either 0 or 1, depending on what happens. And so if we plug that into the color, my assumption, this might not actually be correct, is that if it's 0, if 0 is the output, every vector is going to be 0, so it should be black. Otherwise, it should all be 1, so it should be white. So if I were to save this, I should see a ring somewhere of white. Or not. Let's see. We get our distance, we plug it in there, that's our edge. Let's switch these. Nope, okay. I don't know why I thought that would change anything. It would have just inverted it if I had done that. Instead, all right, let me see. I am expecting this to take the world space position and the ripple location, get the distance between those two, output the distance between those into this step, and compare that to our ripple radius. Does it, And then we plug this output into our color. So I should be able to multiply that by our inside color, if I'm doing this correctly, and output that to our shader's color. So now we should get purple, black. Shoot, it's not working. All right, let's make sure our distance function is actually doing what I think it's doing, because clearly I'm not getting the results I want. And so let's skip the step, because I think that's just complicating things. Let's go around that and just take the output of our distance and plug it into this multiply. So we should get a ramp of purple. And if it's all flat, okay, it isn't, that's good, then it would have been wrong. Something would have been going on. Since we know it's not, we can actually tell that we're getting a distance, a difference. And so what this is actually showing us is sort of a heat graph of the actual distance from it. So black is 0. That's where our point is. And then as we move away from it, it gets more and more intense. As the distance increases, it multiplies this purple color by that distance. And so it just gets significantly more intense until it gets white, and we lose all meaning. So my step function is wrong. And so based off of what we learned in the previous video, a step should have something return 0 if it's greater than and 1 if it's less than. And that's not what we're getting. So I should expect, if we plug this into the input and this into the edge, we should be able to plug this into the multiply function. And now we get this with a ripple radius of 1. Oh, I see why we're wrong. Our ripple radius is 0. For whatever reason, I was reading this. So this property says ripple radius 1 in parentheses. But the actual value in the shader is 0. So I should be able to increase this, and we should see a black circle appear. That's where I was going wrong. That's why everything wasn't working, because I had made assumptions that were not correct. So I should be able to flip those, and we should see it invert, which means that our inside color, our purple, is now inside the circle. And so now we just need to invert that. Let's do a 1 minus. There's a math function for flipping something. Because this is purple, this is what we want if it's inside, but we may not necessarily always want the outside color to be black. As it is, this works if we just want to have like ripples add a color, but if we want the outside to be some other color, this doesn't quite work, and so we need something else in order to accomplish that. And I don't know what it is. 1 minus? Doesn't look like there's a simple way to do that. Negate, normalize, don't know what that is. Reciprocal. Okay. Cool. So let's multiply this by something else. Is there an easier way to do this? I don't think so, unfortunately. We might be able to like smooth out the transition, but I'm not sure I want to do that, so we're not going to do that. Actually, I lied. I'm curious what'll happen, so we're gonna test this. We're gonna take out the multiply, and we are going to plug in the inside color as edge 1. The outside color as edge 2, and the output of that into the input of that, and take the output there. If this works the way I think it does. If the color goes below the edge 1, it becomes one color, and if it goes below the edge, or goes above the edge 2, it becomes the other. So my assumption, this might not actually happen. We got green? Question mark? Okay. Let's ignore this. That was a stupid idea. That doesn't work. Okay. Bad choice of thoughts. Let's just go back to our multiply, because multiply we know will work. And that makes a heck of a lot more sense than what I was trying to do. So inside color times the output of this is going to be the inside. But then we also want a subtraction, which is going to be 1 minus this. So 1 minus this is just the negation. You can see it's white now instead of black. So if we plug this into a multiplication of this whole thing, let's move that up there. Multiply. Sorry if this is getting a little bit messy. I'm just kind of adding things until it works. We can probably lose the world space stuff and get a little longer here. So we want our outside color times the negation of this, and we're going to plug that plus. Do we want to add them, or adding should be fine because it should only be one or the other, because this step is going to return a hard value, either 1 or 0. So if we add these two, we're only going to end up getting one of them. So we'll either get black or we'll get purple. And we would never get a black plus a purple, or the outside color plus the inside color would never happen. You would either get the inside color, all of the inside color, or all of the outside color in the way this is set up. So we get black on the outside and purple on the inside. So what we should be able to do now is change this to say blue, teal, or whatever. Red, sure. And then change the outside color as well, and we'll get something else. Actually need to change, there we go. Change the actual intensity of it. And now we get this nice multiple colors. That's kind of a weird look, but you kind of get the idea. And because we did an unlit shader, there's no lighting happening here. So these values are whatever you plug in is what you're going to get out. It's not going to light it. This specific shader, even though I point the light at it or even delete it entirely, The outside world will change, but this shader will not be affected by that. And for what I'm trying to do, that's perfect. If you don't want that, use a Pbr shader, and that will actually do lighting, it will do global illumination, and all of that other stuff it will handle for you. You could probably add lighting to an unlit shader if you really wanted to. Like if you wanted your own custom lighting, for example, that might be one way to do it. I probably wouldn't recommend it that way. There's better ways to do custom lighting with shaders, but that's an option. So this is sort of our gross red and yellow or gold or whatever you want to call it thing. There, that's probably that's still not much better. Bad color choice. There we go. So you sort of get the idea. This way we get a nicer solution, and we can actually change these values. So I can actually move this circle around now, or increase its radius, or change the colors as I've been doing, and everything just sort of works. That wasn't possible in the previous one without compiling a new shader, which is not something we want to do. This allows us to reuse this a bunch and get different results. And that's sort of what I was going for. Plus, we used steps and stuff, and that was nicer. The math gets a little bit funky. I wish there was a cleaner way to do this, because like this entire bit and this bit of the subtracting and multiplying and taking all of those things to get a new color is something that you could do in like a single line in code. But here we're using multiple nodes to accomplish that. Maybe we could write our own custom node to do that. Maybe there is a node and I just don't know what it is. Again, I'm learning this tool, just like theoretically you are, or maybe you already know it, whatever. But this is how I'm learning the tool. And so there's still things that I don't know. And if there are things that exist, let me know and we can use them in the next video. That's what we did with the step and smooth step. So I'll leave it here because this is just the end. But I think that's it. One thing I am kind of curious about is, does it handle like alpha transparency? No. So if you set the alpha to 0.5 like I just did, it doesn't get semi-transparent unless you change this to a transparent shader. Bet that would help. Cool. Okay, so that gets semi-transparent. I suspect when I did that, it no longer casts shadows. I'm not going to get into why that might be, because that's a whole complicated topic. But transparent shaders typically will not cast shadows because they're rendered at a different time. If you want to know more about that, ask and I'll do my best in like the comments or a separate video or something like that. But that's it for this video. I'm just kind of poking at it at this point. So we'll move on with this and get it so it sort of animates and does some extra stuff in the next video. And then we should be sort of in line with where we are at with the actual surface shader version of this, which we've been doing kind of in line with this. And then once they catch up, we should be able to kind of do both of them at the same time and kind of see which solution works best in certain scenarios. Because there's going to be some things that are easier in Shader Graph and some things that are way easier in code. And hopefully we can kind of figure out what those are and kind of draw connections between them. At least that's the hope. So hope to see you guys in those videos, but that's it for this video. So until next time, see you, internet.